Thank you very much for the invitation. Thank you very much for the invitation and for considering me for this interesting contribution, interesting forum. I thank you very much, the professor that invited me, because it is a very good opportunity for showing. As it's not a work, it's a series of works that has been done from myself and other people. And I presented, as you can see, in Turkey at the beginning of this year at the FAO event. The title of the talk is Integrated Fisheries Management. Are we really running before we can walk? The title is a little bit provocative in the sense it is trying to discuss if we are really doing too much according to the current knowledge and tools. And I think I will bring you during this presentation to answering to these questions. This question. The first of all, the starting is the elephant in the room. So it is so amazing, like the ecosystem is actually what we are taking the fish from the ecosystem, right? So it seems unavoidable that we consider the ecosystem and the integrated approaches as a main tool for managing fisheries. In reality, this is really a kind of hidden big element in the room that nobody want to see. And so I will talk about this complexity of what we mean by integrated fisheries management. Well, fishing is of course is the activity of taking living animals from the sea and send them to the market. But in reality, the dynamic of fisheries is also depending from a series of things that are not only the market requests, but also the environmental, as we know, and climatic changes that are affecting the resources. The all the policy and institutional interventions in terms of regulations, but also the fact that there is also interaction between species. Basically, we need to consider the environment when we want to make a sustainable fisheries management. And the environment is not only the environmental and interaction with the fishing activities, but also the interaction among living species, and also considering the socio-economical interaction. So also institutions, markets, values. Practically, we need to consider technical interaction among fisheries, interaction among species, effect of climate change, anthropogenic other effects and pressures that can influence the species. So we have a series of things that potentially we need to account for doing sustainable fisheries management. In reality, there are already a series of tools that are implemented for fisheries management. They span from single species stock assessment models to functional group modeling, multi-species modeling, and also ecosystem models. All these approaches are already developed in a different degree in different parts of the world. But my understanding and my point here is that not always they have a very good integration with all the aspects that I've just shown in the previous slide. So there is a need to integrate more these tools with all the different other processes that we were thinking of. Why we really need to do integrated fisheries management? To try to explain, I'm using this graph where actually we have a dynamic of potential catch that we can estimate. This is actually the real, in the blue, you can see the real biomass that can goes in the dynamic of the biomass in the system. And of course, when we look at the past dynamics, we can try to find with stock assessment tools that do not embed the climatic changes and, for example, the influence of temperature. We can somehow understand how the past realized catches dynamic, how it was, how many catches there were, and we can have an estimation of how much was the biomass in blue. But when we project for the future, if we didn't really include the climatic variabilities, but it was also only embedded in our stock assessment tool implicitly, we can run out in a very big mistakes in which actually the catches that we foresee for the future are really hampering and disturbing and actually are at a level that are not sustainable for the real living resources. In some sense, if we allow the past to be represented with implicitly representing the environmental variabilities and not explicitly representing them, we cannot make very good projections for the future. So the dimension of the changes in the dimension of the population, if we can, is independent from fisheries, right? And the tools that we need to use are tools that need to explicitly represent how climate and other factors influence this biomass in the future. Uh, of course, we have the evidence, since most of the stock assessments are not really embedding environmental variables, are not often embedding temperature, they are still working. But this is a question of really, is a matter of how far we can go. So for very tactical projection, so for very short-term projection, the stock assessment is still working well. But if we really want to make strategic visions, more longer projections of more than a couple of years, we really need to include in our tools also the environmental variables explicitly. So we really need to include these variables to understand how they were driving the past and how they will drive the future. This is the best way actually to make a more robust prediction of what can be the future sustainable catches. Also, you should note that not only for a strategic vision, we need to include explicitly these environmental factors that are potentially related, for example, to climate change. But also, we are forced to include these factors, especially for short-living species, because the short-living species are more, the past few years are telling very little about what will be the next few years, while they are very much more sensitive to environmental factors. I'm thinking especially of small pelagic species, for example, or cuttlefish. These kind of species are probably the ones that need more the representation of explicit representation of environmental factors. And of course, we need to represent especially the environmental or climatic or whatever other factors that are influencing the resources, especially those processes that are very, very quick changes, that have very fast changes. I'm here you can see it's very general, but if you think this can be applied nowadays in, for example, to temperature. Temperature is changing very fast and is actually producing, we have scenarios for the future for temperature, but often we don't have this temperature represented explicitly in our models. So we need to do that. So the question that I posed to the question that come out is um, with our fisheries management measure that nowadays are often projected without explicitly representing, for example, the climatic changes. Are we really projecting what are the fishery results? So, what are the changes related to the resource because of fisheries, or are we running year after year after changes of the resources that are really coming from other factors? What I'm thinking is that there are areas like, for example, the Mediterranean Sea, where there are constantly evidence that we are overfishing, and even if there are very large, important management measures that were done to reduce the overfishing problem, the species are still in overfishing. So the problem is that, in my view, is that in some cases, it's not a problem of fisheries itself. It's a problem of the resources that is driven by other factors that influence the biomass. And with management, we are actually running after these changes that are due to other factors, not to fisheries. This is very important to tell because there is a great frustration from the fisheries industries that they are trying to catch up with the management rules and the management targets, and they are struggling to reach these targets because basically the resources are nowadays changing for factors that are more important than fisheries, like, for example, temperature and other climatic changes. So my point here is that we really need to embed these variables, these climatic, environmental variables, to integrate them into our management tools. Otherwise, first of all, we miss the target. But secondarily, we are not clear with the people that we are managing, the fishermen, that we are missing the target not because of their fault, but because there are other changes going on. Um, I think there are opportunities for embedding these environmental variables in the future with projections, because there are several tools produced now worldwide that they are projecting what will be the changes at the sea in the future. Here there is an example for the Mediterranean Sea, where you can see there are a lot of information in this graph. But basically, we have a couple physical biogeochemical model for the Mediterranean Sea, and these kind of models can project what will be the future of the oceanographic condition in different parts of the Adriatic, in the water column also. So you have the first row, you have the water column, the first 100 meters, and then in the second row of graphs, you have the deeper areas between 200 and 600 meters. So we can project into the future, starting from the knowledge that we have nowadays, what will be the changes. And the changes are, of course, temperature. You see here in the first graph on the top, where there is the projection of changes in the temperature for the future. Here you have two different scenarios, the RCP 8.5 and the RCP 4.5. The 8.5, for those that don't know this naming, is a scenario that is assuming basically a continuous use of fossil fuels and other anyway the production of CO2 will not be much limited, so to reach 80, 150 part per million ppm of CO2 in the atmosphere, while SCP 4.5 is a kind of moderate scenario for the future, where the increase of CO2 in the atmosphere will be a little bit, well, reduced a lot by behavior of the people and policies. So you see that in both scenarios there will be an increase of temperature. But not only temperature, you see that the salinity is having also some changes. What is most important anyway for us is that, for example, if you look at chlorophyll, chlorophyll will also be kind of less, there will be less chlorophyll, so less primary production in our seas, because basically there will be more stratification of the water column. and so less productivity in the upper layer because there is a nutrient depletion. But look also what will happen with the oxygen. Oxygen is also another variable that is expected to decline in the future, both because there will be a transfer with the atmosphere, but also because there will be more demand for consuming the organic matter at higher temperature. So basically, our ocean will change for many different aspects. Temperature is the one that we know quite well. Salinity probably will increase. Oxygen is expected to decrease. Primary production is expected to decrease. But also look at pH that is expected, of course, to move toward a more acid situation. This happens not only in the surface layers, it's happening also the deeper layers, of course, at a different rate, and we can project this for the future. So the idea is this information that we have, and these are kind of quite reliable information for the future. Of course, it depends on the scenario that we apply, but there is the potential to forecast what will be the future. It is important, therefore, to link this variability with what will happen to the resources. We know that it's difficult, but this is a necessary step to link not only temperature but all these other variables to what's happening. And the need to integrate environmental factors is starting also from the physiological part. So we can start looking also of how much the temperature is affecting the individual species through the physiology. There is this work that I show here that is showing how many stock assessment models are detecting influence of warming in the productivity. This is a work regarding 235 fish stocks, and as you can see, there are 19 stocks that will be negatively affected by warming, and 9 will be positively affected by warming. So we know that not all species will be negatively affected. Some will be positively affected, but the problem is that you see, it is the temperature changes in the future is expected to have an effect on the MSY, so on the target of fisheries, that is the maximum sustainable yield. In a different way, you might see that some areas are areas where the MSY will change negatively in an important quantity. All these numbers are indicating the number of species. And of course, when it is red, it means that the future of, the maximum sustainable yield is impacted by these warming scenarios and by this warming that has been also occurring in the past. Basically, this is a very large analysis, and in this showing that even in the past, we can detect that the sum of the target that was set by fisheries were actually driven by warming, not really driven by the policies on the management. And therefore it is this work is in some ways showing that this hidden factor that was not really considered in the analysis and the original stock assessment is actually one of the factors that were also influencing in an important way also the maximum sustainable yield. You see that only the warming can affect by the order of 35% more or less the MSY. So it's a huge quantity if you consider. The same work is also showing the losses from populations that are responding negatively to warming. And these populations, the 19 populations, are overwhelming the population that are actually positively affected by warming. Basically, the general MSY for all these species that were analyzed, there were more than 200 species, is declining in the last years, and the effect is basically the effect of climate. So, preventing overfishing and developing management strategies that are robust to temperature-driven changes, and I would say also that explicitly represent the temperature-driven changes, is essential. Basically, the stock assessment that were done in the past were not considering temperature explicitly. It was only implicitly represented. And therefore, the management was driven, of course, the fishermen was trying to follow the MSY, but there were not real understanding that this MSY was driven by other factors. And these other factors in reality are very, very, there is a trend clear, and there is an effect that is very important. Basically, the factor affecting MSY was climate and warming. And it was an astonishing result, the fact that for all these populations, there is a declining in the MSY, basically because of the negative impacts of the warming. The fact that we need to integrate environmental factors into physiology is evident from many works. Here there is a work showing that the fish body size changes with temperature. It was an analysis related to more than 300 coastal marine fishes, showing the changes in mean body length for 1 degree change in surface temperature. The results is showing that for a median length of 15 centimeter, the temperature with the temperate fish with a typical body shape will actually have a change in body size of about 12%. So 12% change in body size for each degree of temperature increase is an amazing quantity. It means basically that there is an expected huge change, not only in the population, in the biomasses, but even in the physiology of the organism will be affected by the temperature, and therefore the capability to grow as we know them. And for many species, there will be a decline in size, average size, just because of temperature. For other species, there will be an increase in size. Basically, if the rate of body size change and warming observed over the past 20 years is maintained, these authors are saying that with 1 degree of warming over the next 40 years, there will be approximately a result of about 40% change in fish body length. So it's expected a massive change in the physiology of the species and in the emergent size of the species. The authors are also saying that the body size responses to 1 degree temperature change through time were about 10 times faster in the last period than those seen through in different spaces. Basically, what they are saying is this is not relevant to where it is occurring. So the species it doesn't really depend if there is tropical or any spatial variability. What is the most important effect is that this temperature change is very fast also in time. And it is expected for the next future a shrinking of many of the species. And this is also an important thing that we are also seeing in many seas. For example, in the Mediterranean Sea, there is there is evidence of a decline of the size of small pelagics. But can we really integrate these environmental factors into physiology? Well, yes, sure. We have several tools, even the most simple bioenergetic models that represent filtration, ingestion, digestion, investment in somatic and in gonatic growth. Well, these models are actually the best way to implement and integrate environmental factors. Because with this kind of approaches, for example, that we have here represent for a mussel, but we can have it for many species, we can have how the environmental variables influence the different processes in the bioenergetics that can be transferred into the growth and they can be transferred into the population dynamics. So there is the potential and we have the tool for doing it, even nowadays and even for many species. But the question is how many stock assessments really explicitly include the temperature or other environmental factors? Well, I don't have statistics, but according to a presentation that was given by Professor Underpant, very few stock assessment models include explicitly these factors. And we are talking about an order of few percent, 1, 2, 3% of the stock assessments worldwide include these factors. So you see that there is a lot of work to do because even from the basics, from the physiology and from the stock assessment of single population, we really have space for improving and for including this, integrating this environmental variable into the dynamics. And in this example, we were, for example, representing different factors that we have from oceanography, like suspended organic matter, temperature, chlorophyll, and all these factors were oceanographic driven and influencing the biology of the physiology of the species. Um, there is another point. Of course, the fish is moving, right? And so the fish is are trying to move according to what are the best environmental conditions. Of course, this is done at a cost, but it is possible to embed even in spatial distribution model the environmental variables. So here is an example for the Alaska where the actually different species are modeled with different tools, different kind of models, and basically the authors embedded into the species distribution also several oceanographic factors, including the current, the depth, the slope, the aspect, the bathymetry, the bottom temperature, the tidal current, the sedimentation, etc., etc. So uh, even here, when we are talking now, always by at this stage, we are still talking about single species. But the point is that we are talking about single species also in space, and we have the information that I show you regarding the oceanographic condition. We have them three-dimensionally. So we can use these as essential oceanographic variables to be embedded into our species distribution models to improve them at best. We have done, this is an example for the Alaska, but we have also done in the Adriatic Sea, for example. This is a work that we published where we use the troll survey data, so the information about where are the resources. So we have the indices of biomasses abundance for key species, and we integrate this information with the physical and biochemical models and model results at a very high resolution, more or less 6 by 6 kilometers. And you see, we integrated several different variables, oceanographic variables: chlorophyll, temperature, dissolved organic oxygen, nitrate, phosphate, salinity, pH, and particular organic carbon. We integrate also information about anthropogenic activity, like the fishing effort that we estimated through VMS, so the vessel monitoring system. This was an exercise that was able to integrate, therefore, information about the resource, information about the environment, information about the anthropogenic activity, using a set of very different models. And the result is that on the left you can see some indicators of how the models are behaving in terms of capabilities to represent the data. And basically you see, and we actually use a different kind of approaches, adding once by one different variables. So starting from A, we add oceanographic variables. Then in model B, we added new environmental variables, etc., etc. You see that while we add environmental and anthropogenic variables, we increase the potential of explaining more the data, and so we have better and better models. And so the first thing is that these information oceanographic variables are represented in an explicit way, and you see also that with this kind of approach we were able to represent the best distribution of the species and to identify the hotspots of aggregation, both for juveniles and adults. The idea is that these kind of tools are the best ones to integrate the information that are collected by troll surveys with the oceanographic information to obtain the best representation of the distribution of resource, and for example trying to use this information for planning future marine protected areas, future fisheries restricted areas, and that can be, for example, targeting adults or juveniles of the different species. So basically, with this tool, we are able to identify the essential fish habitats in terms of spawning or recruiting areas, and growing areas, nursery areas, and that can be the best places for place management, spatial management activities. We did also for other species in other parts of the Mediterranean Sea. We are actually currently working in different parts in the Sicily Channel. We are working in the Alboran Sea with these tools, and also the level of the whole Atlantic. Just to show you a result for the Adriatic, basically we can look at the overlap of the hotspot for several species. In this case, you have the several species target, 7 species target of the otter troll on the left, and on the right you have the 3 species target for the beam troll. They are two quite different gears. The otter troll is targeting mainly the Mercer species, and the TBB, so is the beam troll, is targeting mainly benthic species. When we overlapped the hotspots, we actually identify the areas where it's the most important areas for aggregation for adults and juveniles of the Mercer species and the benthic species. And you see that we also were actually overlapping with the areas that are currently uh, thinking, or where they are practicing some spatial management, fisheries management. So, for example, this area 2A is in blue, is the Pomo fisheries restricted area, the biggest fisheries restricted areas in the Adriatic and in the Mediterranean Sea. And you can see that it was placed in a quite good way, in a quite good place, but there are also several areas where it will be worth placing new restrictions. You see here there is a canyon, and there was foreseen a protected area that is now in place, and you can see that this is a good spot. But what it emerged from this analysis is that there are several other good spots where, if we plan protection, we will actually have a better benefit, an optimized benefit for the resources. You can see, for example, on the right side, for adults and juveniles, for the benthic species, there is a hotspot of aggregation in the central part of the northern Adriatic here, where it is planned to have this green area that is planned to be protected in the future. And you can see it is a good place for protecting adults, but not exactly the optimal place for juveniles. And so we think that tools like these that are integrating also environmental variables are not only becoming more and more accurate and allows the models to be more accurate in representing the distribution of species, but they help a lot to place the protected areas in a context also of future changes. Uh, for example, we apply to the same tool the expected changes for the future in terms of sonographic variables, and we observe where the species are moving. Most of the species in the Adriatic will move north, so we'll lose the green areas and will move, the hotspot will move in colonizing new areas, if possible, that are in red. You see that there are species where there is very little of new gained areas, like Norway lobster in the Adriatic Sea, is expected to lose areas of aggregation, a hotspot of aggregation, and to have no increased gained areas of aggregation. So these species basically will have a shrinking in its areal of hotspot of aggregation, in its um, essential fish habitat. Other species, the essential fish habitat will move, and we can predict where it's moving. So the idea of this analysis, of course, is difficult to make a plan. This is a forecast for 2050, but it is giving an idea what will be the effect if we make fishery restricted areas nowadays, and how much will need to change to be affected in the future. In the future, probably some protected areas might shift in space, also to account for this shift of the essential fish habitat of the different species. This work has also been published this year, and you see it's a forecast. In also in this case, we are using the RCP 8.5, so the worst scenario basically, and the results are interesting because they are showing really a potential shift of the species to north, just because of the climatic change conditions. Um, I think these kind of tools and approaches are more and more necessary all around the world, because the species are moving, and they are moving very fast. The species are doing a quick spatial displacement in these years because of the changes in climatic conditions. I report here a case, is the case of mackerel in the North Atlantic. You see, these are the data about the distribution of mackerel in from 2007 to 2016, and basically you can see that the species has been moving eastward a lot, and the species that were practically up to 2010 concentrated around between Iceland and Norway is shifting and is occupying a large areas between Greenland and Iceland, and this is creating a lot of troubles, not only because for understanding how much is the biomass of this species, because it's changing the area. You see, the initial area of aggregation was actually is reported here in gray, and it was actually very close to Norway. Imagine that not only we have problem in estimating the biomass of species that are moving in this way, but we also have problems in making management. because in a system, for example, like the one in the Northern Europe, where there is a quota system, it's very difficult to adjust the quotas according to this shift, and especially it's very difficult to make the countries to agree on these shifting quotas. Imagine that the quota in the past was mainly given to Norway, okay, and it makes sense to make the quota very high for Norway in the past in 2007. But when you go to 2016 and you say to Norway, well, the quota will be much less and the bigger proportion now is shifting to Iceland, you can understand that there are big issues because the countries don't want to really agree on these important changes on quota and on the limitations induced. So it is fundamental to know very well how the species are moving, and it is important for better scientific understanding, but also for management issues. They can create a lot of issues. Um, in particular, then, one of the problem is our definition of stocks. The definition of stocks in our stock assessment is usually based also on boundaries that are most of the time created considering administrative boundaries, because they are considering data statistics and how the information are gathered. Uh, Practically, the shifts that we are observing for species are also making troubles to this definition of stock units. And one question that will arise is these climate changes and all these modification really so much important that we need to redefine also our stock units for stock assessment? I think this is true in many cases. So in cases, the stock assessment units are really needs to change because, or at least to account for these modifications. So again, the integration of information from the environment would be essential for understanding these changes not only in time but also in space. Um, the the fact is that there are already not only physiological model but also species distribution model are very widespread all over the world, and is really needed is to embed more all these oceanographic changes. And we have very good products in terms of oceanographic conditions and products that are available online at different resolution in time and space, a different vertical resolution. And here I'm reporting the reanalysis of for the Mediterranean Sea that also assimilate information from satellites, information for Argo buoys, and so there are the potential for these tools. These tools improved a lot in accuracy in the last decade, and so are important source of information because it's the best integrated vision of the ocean. I think these kind of three-dimensional oceanographic variables are very important for making projections, and not only in terms for species dynamics over time, but also for species dynamics in space. Of course, one thing that we might also remember to add is that the species are not living in isolation. So most of the approaches that I show now, till now, that are regarding physiology, that are regarding distribution of species, are were actually problems looking analyzed in terms of single species. In reality, species are moving together, and they move also because of other species that are moving. And therefore, it will be important in the future to consider the joint species distribution. So, how to represent the fact that the species are moving together, or we not only because of environmental changes, but also because other species are more affected by environmental changes. In particular, I think we should move towards integration of multi-species multi-gear, and ecosystem approaches to embed different stressors. I think we should consider the fact that fishing mortalities are coming from different sources, are coming from different gears, are also because of the discards. We should also account for the indirect effect of indirect impact of fishing, direct or indirect impact of fishing, including for example, the effect on habitats. Habitat modification and destruction is super important, and we might include them to our projection, including also the climate change and including other activities in order to evaluate the trade-offs. Best activity we can do in the future will be to not only include these oceanographic climatic changes, but also to represent the ecosystem as a whole, in which the humankind, is part of this ecosystem. We have several tools available that we can use to do that. They have a different degree of evolution. We have a very famous ecopath with ecosystem, but we have also Atlantis. We have mice models that are models that can be adapted in resolution according to the problem. We have models that exploit the fact that the species are well connected. The processes in the sea and the interactions are also size-based, strongly size-based. So there are models based on size. I think all these approaches are valuable. All of them can embed the complexity, a different degree of complexity of the system, and can be applied according to different data availability and question. Most of them are not operational, that's true, but I think we should quickly move toward using them more and more because they allow us to represent the multi-species, the multi-gear, and the multi-environmental variables effect altogether. Some deeply integrated tools already exist. They appear to an external person like super integrated, where you can have the dynamic of a football model size-based integrated with a dynamic bioclimatic envelope affecting even the recruitment, adult and juveniles, and the productivity of the species according to, so the physiology is adjusted according to temperatures, oxygen and acidity, etc. These are models that are, as you can see here, affected by several different factors, and they are integrated one to another. So are tools that basically representing explicitly the effect of these environmental factors on the physiology and transferring this effect into size-based functional models. And this is an approach that is already currently applied, and is also used, for example, to forecast future changes in catch potential according to different scenarios. And unfortunately, all these scenarios are showing that in the future there will be a decline of catches, catch potential, and especially in the tropics, with independently from the scenario and independently from the model that was used. And this is also was obtained also from a set of models that were applied at the global scale, looking at projection in the future. And most of the approaches are telling us that with future climatic changes and effects, we are expecting, unfortunately, a decline of the biomass at sea. So the potential catches, of course, will be declining, and this is especially true in scenarios that are considered now a little bit unrealistic, but is the worst scenario 8.5. But even in scenarios more mild, like RCP 2.6, you see that the future that we have in front is a future where there will be less potential for exploiting the species that we currently know. Of course, there will be other species that might be beneficial, they take a beneficial benefits from the climatic changes. These species are or unknown or not interesting now for the market, but yeah, so probably this means that in the future we might also need to change our habits. Um, just to give another example, how we use, I also use again the Adriatic Sea, that is the area where I'm working mostly. And we develop a quite complex model with 73 functional groups from phytoplankton to the top predators. And we represented the complexity of phytoplankton, the complexity of fisheries. So fisheries was describing more than 30 fleets, and we used 20 years of data to build and calibrate the model. 20 years of data that include troll surveys, this oceanographic, biochemical, physical biochemical model data. And we run the model not only in time, but in space, with a spatial resolution of 1/16 of degree, that is more or less 6 kilometers by 6 kilometer grid. And the model is uptaking the environmental variables monthly. You see that there are some changes in the bottom temperature, in the phytoplankton, and also in the salinity. And we also not only introduced these dynamics from the bottom, but we represented, for example, the fishing activities with their administrative boundaries. So it is possible to build these complex integrated models. These integrated models, of course, they have a lot of problems in terms of well, the accuracy in representing the data. But at the moment, they are the best way to integrate administrative policy, oceanographic conditions, and basically we use drivers like fishing effort catches, time series of catches to drive the model for 20 years, and also biogeochemical information like the high frequency data regarding the seasonal cycle for phytoplankton. Here you have different kind of phytoplankton, diatoms, dinoflagellates in different areas, and you see that we are trying to repeat the seasonal cycle and the high variability dynamics that we observe in the biochemical modeling. The result is that these models are fitting the data in a reasonable way, but there is for improving. You see here the biomasses and the catches for two species, anchovy and deep roe shrimp, and basically, we can represent usually quite well the catches. These are just two species that we took as an example. But even if you have all this data, all this integration, the problem is that we have a lot of noise. And here you have very different scenarios of fitting. These are all different scenarios of fitting that were applied to this complex model, considering the forcing and considering the effort dynamics. There is a lot of space for it, but we were quite happy about the model able to capture main dynamics of the species in this way. You see, it's not a very accurate model, but it is very realistic in the sense that represent the majority of processes going on in the sea. And with this kind of model, for example, to do what if scenarios. So make scenario analysis, for example, testing fishery restricted areas, testing scenarios of a situation like now, so what we call scenario zero, or closing the coastal areas to trawlers, reducing the effort of trawlers. That was also foreseen by the multi-annual management plan, or reducing the effort and implementing new protected areas. You see that we set up the fishery restricted areas in Como, but also the Bari Canyon in the south and also another area in the north. What we also did, we were also representing the effect of climate change. using the results from the biogeochemical model and in particular the scenario LCP 8.5. The first thing that we wanted to analyze was, and you can analyze with this kind of tool, is the effect of the different fishery restricted areas. Here you have the three main fishery restricted areas that were placed in the model. So you have the Pomo Pit, Bari Canyon, and in the North Adriatic you have what we call Sanctuary, Northern Sanctuary. Well, you see that the effect of the three different areas is very different. And basically, there is a size effect. So the Pomo Pit area is bigger and it has a very huge effect, especially on some species like hake and nephrops. Um, and so size matters. This is, we know that. We see also that when we make a fishery restricted areas, we can foresee a super high increase of biomass within the area, and we can also represent the spillover on the right. And you see that the spillover is actually, while the biomass inside the protected areas can increase also by 300%, so the biomass can double and more. And of course, at the level of the basin, that is the stock unit, the biomass increased by 5% and 10% at maximum. 5% for nephrops and 10% for hake. But yet these are very positive effects of these large protected areas like Pomo Peak. You see also that a smaller area like Barrio Canyon, even if they are in very optimal position, they can increase the biomass inside importantly, but not having much spillover. And you can also see that the North Adriatic Sanctuary is an area that is not really efficient for protection because it has very little effect on these species. What about other management scenarios? I'm going to the end, but just a few minutes. Well, we compare the scenarios where we have the coastal closure 6 nautical miles to otter trawl, the effort reduction and the representation of the fishery restricted areas, and also climate change. You see here the relative changes in terms of biomasses for these 8 species that are the most important commercially. Well, the first thing that you can observe is that coastal closure has a minimal effect. So it's a controversial measure. These kind of integrated tools show us that making the coastal areas up to 3 nautical miles close to otter trawls will actually increase a lot the effort outside, making a huge depletion of the larger individual outside the 6 nautical miles, with negative indirect effects on many of the species. So you see the biomass is also declining, even if I have increased more the protection. More effective is when we have the effort reduction. The effort reduction here represented was in the order of, I think was 28% in total, but more or less is consistent with a 12% declining effort. You see that some species are taking a lot of benefit for this, especially hake and red mullet, and increasing in the order of 10%. If with the effort we include also the fishery restricted areas, so effort reduction plus fishery restricted areas, our model was showing that we have even a little bit better benefits, especially for mullet and hake, a little bit less for mantis shrimp and nephrops norvegicus. But then what was the astonishing result? Is the impressive result is when we put climate change. When we put climate change, our management measure basically doesn't matter anymore because the climatic changes are actually totally negative, affecting negatively the biomasses, more or less like it was foreseen in literature also. And so we have to be careful because even if we are going to have large protected areas, reduction of effort, this will be counterbalanced. The positive effects of these measures will be counterbalanced by climatic effects. The question is, this is, for example, the catches. Before there were the biomasses at sea, and here you have the catches foreseen for the future in these four scenarios. Of course, the scenarios with fishery restricted areas show a little bit of increase in the catches, but the most amazing result is the fact that the catches of many species are reduced in the future. And why they are reduced? Why the biomass is declining and the catches are declining? Basically, this is a change in primary production. The overall primary production more or less is the same, but is changing the size of the phytoplankton that is producing. So basically, the biogeochemical models are predicting a reduction of about 10% of the large phytoplankton and an increase of more or less 5% of the small phytoplankton. But because of the different ecological route of the energy from the small phytoplankton to the large phytoplankton, this is the effect. Basically, it's not the same for the ecosystem if we have smaller phytoplankton more abundant than large phytoplankton. And this is affecting negatively the system. We think that this effect is you can see in many other places. These kind of tools can be used also not only for look at the fishery restricted areas and the effect of climate change, but they can also be used, for example, to represent the effect of nutrient enrichment. So the nutrient that is discharged to coastal areas, how it influencing the marine ecosystem. This is an exercise that was done within several models in the Mediterranean and the northern European seas. And we use several models to represent the hydrological pattern of nutrients coming from the terrestrial system to the coast, and then going into the hydrodynamic model, and then the biogeochemical model, and then fitting into the food web model. The results are that maximum well, this tool, integrated tool, was showing that the effect of nutrient loads from the rivers on the different kind of stocks. But basically, that if we are reducing the nutrients inputs on the coastline, we will have, as you can see, a decrease of the stock biomass, especially of small pelagic groups. For in many of the exercise they were done in many of the models, there are differences of course, but the basal result is that reduction of inputs of nitrogen and phosphorus will result in much lower reduction of C of these nutrients because of dispersal, and then a decline of biomass that on average will be in the order of 5%. So basically, we need to think about the potential interaction among different factors, and in particular, we need to think about the trade-offs between having more clear waters with less nutrients coming from the coastline, but also less fish production. So we need to balance these two things. Do we want more fish or do we want more clean waters? The two things need to be compromised together, and these tools are the ones that allow us to make this trade-off analysis. Basically, the idea is that we might also rethink our objective. Our objective in terms of fishing, in terms of management of the sea, we need to compare the different objectives that the different stakeholders has and look if really the objective of having more food from the sea is an objective that is valid everywhere. Nowadays with the MSY, this is the target, but we can consider other targets that are, for example, maximizing the profit or maximizing the quality of the water, and so other sources of income like tourism. Or if we want to consider targets that actually are more critical because they might have less ecological efficiency, but also less economic efficiency, but will have more people employed. Uh, I think we might rethink in the future about this objective. What will be in the case of many actors, many activities that are going on in the sea, and and this can be done, the management of different factors, considering quantitatively the trade-offs using integrated tools, but also considering integrated tools that can embed the different effects of different sectors other than the fisheries. Um, One of the challenge when we move to these ecosystem integrated approaches is that the solution is not unique. Basically, when we have these complex systems, there is no one optimal solution. There is no one MSY. There is a region of viable good solutions, and there is has to be acknowledged both by scientists, but has to be understood also by politicians, by policymakers, because that area is the area of management of viable solutions, and that are possibly, I will not say equal, but they can guarantee a trade-off between the different aspects. Here is the case where this is a case where there is done management strategy evaluation in management of swordfish in the Pacific coast, where they were using a complex oceanographic model linked with the agent-based model and the species distribution model. The idea is that the management of swordfish is not only affecting the sword fish, but also other factors, others like the blue sharks, like the trip of the other fishermen. So the idea is to set up the best closure. They use several indicators that are describing several different factors, and the idea is that these indicators are capturing the different processes that are going on the use on the sea, the sharks because there is all the protection activity, the swordfish for the fishermen, the turtles because they not only they are protected but they can attract tourists. So at the balance among these factors, set up what was the most opportune choices, and you see the choices can be done by weighting these different factors. So my future, I think in the future, probably MSY will not be used as a target. This is a provocative way of looking at it, but are we really ready to abandon MSY as a target? Because in the future, probably this will need to be done, because MSY will be weighted together with other factors in order to find the best target for a multi-species integrated approach. Uh, we have several different tools that we can use for integrating in size, in diversity, and and also considering different potential impacts on the ecosystem of the humankind. So we can use very different tools. What we have to remember and realize, these tools are appropriate for some analysis, for some approach, for studying some effects, some impacts, and less appropriate for others. But also, these tools have a very great difference in terms of realism, representation of reality, but functionality, generality, but also different accuracy. So if we go back, we see that when we are talking about stock assessment models, they can be very accurate. They are maybe not very realistic because there are a lot of processes that are forgotten. There is no integration, right? And there is no even relationship with other species. Then when we start putting many species interacting, some species interacting, we are increasing the realism and we are keeping accuracy quite a good way. Then we start representing many species, for example, with individual based models like Cosmos, size based model like Cosmos. And here we represent many species in this slope of size. And there is less accuracy, but is a good representation, a good generality of the approach. Then we can apply, of course, statistical models. They can be very good, accurate. And then we can move to multi-species lot coupled terra model, for example. That they are very general because they can be adapted to different kind of populations, but usually they have very poor accuracy. And so on. We can start thinking about other model, other approaches, and then we can add also the football modeling as a kind of a tool that in some ways embed different aspects. Is a model that is a kind of approach that can be applied with Atlantis, Osmose, with Ecopath with ecosystem. It's embracing several species. It's a good realism, but it's some problem of accuracy. The the challenge, therefore, is that in the future we might need to embed different aspects, integrate several oceanographic variables, but we will have the problem of having a good realism but less accuracy. What will be uh, the way towards this integrated approach? I think is basically what nowadays in Europe is called digital twin, and is basically a virtual representation of the ocean that is embedding at best the data observation, the models, and all the knowledge that we have from the science that we have done in the past. And I think the pressure that is given now to scientists to develop these digital twins will be a world step towards more integrated approaches. Basically, let's go back to the initial question. We are still in the process of improving our stock assessment in many places in the world. I know this, and the basic stock assessment needs a lot of data, and we are still improving that. And these approaches that I'm mentioning about integrating different aspects will add new burden to the managers and to the scientists. And so the question is, are we really running before we can walk? So we have problems in doing stock assessment in many places in the world. Should we really run towards these integrated approaches? Well, I think so. I think so because it is important for Mediterranean Sea and Black Sea, but in any places in the world, we need to run, even if we don't walk. Even if we don't have very good stock assessment tools, we can develop integrated approaches, and we can apply multi-species models. We need to start, and the best figure that I have is those of the children, the kids, that maybe they don't really walk very well, but they like very much to run, even if they don't work very well. So we need to be inspired by them. And so even if we don't have very good detailed information and we are still struggling to do stock assessment, my feeling is that we should try to go and move toward these ecosystem integrated approaches in any way. Thank you very much. I thank many projects that have supported the work that I presented, and especially I thank the group of oceanography here on OGS that they contributed indirectly to many of the works presented here. Thank you very much. And I'm here for the questions, of course.
Yeah,
Thank you.
thank you, thank you. It's very interesting talk. And yes, we need to think about now the single pieces MSY management to much more integrated with the physiochemical variables into the fishery system. It's very essential nowadays. It's not developed in the most of the part of the world, but still the fishery system in the most of the developing country, they are still working on these MSY things. So it's a time to think about the regional fisheries in the globally, that it's out of the now the things are changing really. We also face the same thing here in Oman Sea, in the Arabian Sea also. Lot of physical or climatic variable change in the oceans. So that is impacting on the fishery resources directly. Might be it's positive or might be in some cases negative. Yes. So it's a very interesting talk. I think it's floor is open for the question and answer. I hope if you have any questions, that please ask him directly, or you can type into the chat box. Any questions? Any questions from? Don't hesitate. If you have any questions, please come and ask.
Yeah, while we are waiting for question,
Yeah, yeah,
I can tell you a question that was given to me when I gave this presentation.
yeah.
And
That's,
they were saying there was a person from, I think he was from Tunisia, and he
uh,
was saying, well, in our countries we don't have a lot of data. Do you think it's really worth doing these kind of approaches, integrated approaches? And I have to tell you that even in our places where supposedly we have a lot of information, we have a lot of huge gaps, a lot of gaps.
exactly.
So if we wait to have all the information necessary to develop a full ecosystem approach, we will never finish,
Not
we will
possible.
never start. And so my suggestion is to start as soon as
Exactly.
possible, because this will also then help identifying what are the most important gaps. And even if you have a sparse data, the best thing I would suggest is to start working on it, because 15 years ago we were starting also here, and we are now at the point where we can say something. If you
Yes.
start now, probably in 10 years you can start also in other places to say something about it. And of course, this has to be developed in parallel with stock assessment, with the development of things. I mean, I will not, I was provocative. I don't think we should abandon MSY. But while we should work with MSY, we should also be careful and look what they are doing in other places, integrating different aspects, not only fishery.
And also there is a huge gap between the subject understanding means in physical science or physical oceanography or coupled with the biological oceanography. So some people are basically that bridge between the biophysical modeling or that is understanding is also still it's not developed in some of the parts. So yeah, so that is the need of means the people should come into integrate and maybe a joint collaborative approach to develop these things. It's also very important.
Yeah. Also consider that nowadays there are several data and also available. And so, and so there is the potential for having some information, maybe rough, maybe not specific for your area, but roughly working for everywhere. And this information are available. And I think we can exploit at best this, because
Yeah,
this would be is a resource. And oh, I think the question
yeah,
about this thing. Well,
yes,
digital twin is. Thank you for the question. Digital twin is a kind of fancy word that was defined recently, and is the idea that we can create a twin of the ocean, so a kind of computerized, completely synthetic world where we can actually understand how it is working and also make projection changes, make changes. Basically, you have to imagine to have a kind of sphere. You will be a kind of, let's say, superior than a person where you can change everything. You can imagine to change, and of course, this is not done just as a game. The idea is to develop with the maximum inclusion of information. So basically, the digital twin at the end will be like an integration of different models, integrated with a lot of information that are used with the public in order to ask to answer to questions. What happens if we increase the agriculture? Then there will be the more nutrient, etc., affecting the coastline, and what is the and then the cascading effects on the food web. The point of the digital twin is that is usually uh, local, is regional. It has a lot of information, it requires a lot of information. They are integrated in different ways. There might be behind it several models. And the idea is that the digital twins have to answer questions. This is, but basically you have to imagine like a huge model that will represent, it will be a copy, a synthetic copy of the reality of the sea.
There is two more questions. I think there's how does the stock assessment model being impacted by global scenarios?
Sorry, I will do. How does stock assessment
Yeah.
being impacted? Well, this is a good question. I show you at one point in the presentation there was this analysis, there was a retrospective analysis showing that for 200 stock, basically the global scenarios, well, the things that happened in the past were affecting the MSY already in the order of an important quantity, like even 30%. So there is a decline in biomass that we observe in the stock assessment that is in the past that is already visible, and even if it was not embedded the climate change, the results were actually affected by the information we're implicitly accounting also for climate. Basically, this is giving you an idea of what will be the change foreseen for the future. So, if we embed the climate in the global changes in our stock assessment, we probably will have a huge influence, and most of the influence are negative because physiology will respond in a way that fish will decline in size. There will be more expenditure for surviving, on average. Then, of course, there will be species that will take better advantage. But basically, the best would be to start representing explicitly into our stock assessment the global changes and try to see to represent these changes in our scenarios, future scenarios for climate, for management. I see also a question that we have to look into several factors.
Hmm.
Yes, the idea is that, well, first of all, when we have a question, we should use the correct tool. This is the first thing. So there is no tool working forever for everything. So if we have a good scientific question, there will be possibly a good tool to use, a best tool to use. Then the second is that it is important to try to think wise and to embed more factors in our analysis, stock assessment, and to use possibly several models at the same time. What we are doing is to make ensemble of models because the models have different assumptions, and when you put them together, the you can have the best ideas. The most reliable idea is actually the one that all the models are representing, right? Independent of their assumption. So yes, then
There's a question also. Could you comment on systems?
system thinking approach or system dynamics.
Yeah.
where ecological, socio-economic factors influencing fishery industry and considering modeling. This is an important thing. There is now the desire to embed social and economy more into any stock assessment, into any management. It is very difficult. I'm also teaching to my students, and when I'm showing MSY, and then I'm showing that there is the maximum economic yield, everybody's saying, why we don't use the maximum economic yield, right? It's the best profit. And the problem is that the word is complex when you use ecology and biology, but when you put also economy, it's also increasing the complexity. It's basically another model that is also have a different dimension because the price, in some cases, the price is locally driven, but in many places in the world, the economy is actually driven for markets can be very far away because the connections are so because of this building a system dynamics model embedding ecological social economic factors is our dream basically. But and we are moving in that direction, but we need to make a lot of shortcuts because
Yeah.
there are a lot of complexity there too. And we are just consider there was a nice work presented in FAO where they were showing the price of tuna in two different parts of the world. And the
Yeah.
price of tuna in two parts of the world, they were very far
Different.
from one another. They were correlated perfectly. So there was no relationship with the stock, no relationship with the with where you are. It's basically the price is driven by the market,
Mm.
and the market is nowadays worldwide, so it's a little bit difficult. But we have to move. We have to also to go and to move in that direction.
Yeah.
I see a lot
So
of
there is a two hand, I think, Dr. Farhad from Iran. Yeah, you can ask.
Thank you so much, Dr. Duta. Do you hear me?
Yes,
yes.
yes, yes.
First of all, thank you so much for arranging this nice webinar. And secondly, I would like to thank Dr. Simon for his nice presentations. I'm not well aware regarding the modeling and the other aspects. First of all, I would like to ask whether these models could be related to the shared stock of tuna. And the second question is why the RFMOs, such as IOTC, ICAT, or the other ones in Pacific or Indian Ocean, why we don't use these models there? If you are familiar, Dr. Simon, I'm the chair of the Working Party of Meretic Tuna in the IOTC, but there we consider only the data limited models, such as
Approach. Yeah.
outcome models, such as data limited model, CMSY, and the other things. I would like you have maybe some minutes to compare these models together because there we rely on the cache data only, not other environmental aspects, and only with some indicators such as FMSY, BMSY, and the other things. Thank you so much.
Thank you for the question. Uh, I have to say that in general there is a tendency to to feel confident in the models that you use, right? And so the people feel confident in keep using the same approaches. I think that even in the approaches that I use now, there is space and possibility to embed environmental variables. You have to consider anyway that, for example, for top predators, might be quite good to represent the dynamics with a model only for one species. The ecosystem models are very well useful when you have a species that is a little bit in the middle of the food web, right? And so it's very important the effects of the predators and the prey on them. In the case of the tuna, is being a top predator is might be good also to use a kind of approach, a single species. But the point is also that maybe mainly is the fact that there is a high reluctancy by the policymakers to accept complex models. The idea is that I prefer a model that is blind with many other factors, but is representing very well the data that I give you, instead of having a model that is representing most of the things in the world, but is not really representing very well the data. So the basics are you have to compare. You have to think that many people think that it's better to represent very good the few data that I have instead of having a kind of rough representation of many things and interaction. I disagree, of course, with this, but this is mostly the view of stock assessment. So the idea is that most of the well, I agree that we have to do stock assessment also with single species, also using the simple models. But many cases there are good advantages also on making integration of information, even because uh, we might discover some gaps and some issues that were not really evident using a single species. But yes, basically, I think we are moving in the direction of in North America now there is more and more work regarding ecosystem models, multi-species approaches. There are some areas where the fisheries are managed using trophy guilds, and this is actually the direction when you have a mixed fisheries, very common. Hope I answered to your question. Thank you very much for the question, by the way. And I hope I presented once at ICAT my works, and they were amazed by the fact that we are considering the ecosystem. There is tuna. Basically, tuna is a right. No, well, I mean, some simplification are useful, but sometimes I think also in that case using different models will be useful. Yes. Thank you.
Thank you so much.
There is a raise hand from Basudhara. Can you please ask the questions?
Mm,
No, it's not online. Basudhara Roy Chaudhary. No, any other questions? Okay, if not, then yeah, we are about to close the session. It's very interesting, and hope we'll make more deep onto into this integrated approach in fisheries management. Yeah. So if there is no question, so we are going to close the session and hope to join in the next maybe any other topic in fisheries and oceanography. Okay, thank you, Simon, very much because you accept my proposal immediately, and your Timothy means your reply is very promptly. So thank you very much for invitation acceptance, and thank you very much for the nice talk.
Thank you very much for the invitation, for this opportunity.
Yeah, yeah,
I'm sorry I had some troubles with the computer,
yeah.
and
No
so
issues. It's all yeah.
and I really thank you. And if you have any question, I will share with you Sanchindan
Yes, yes.
the presentation, and in case there is my email, and the
I
people
can
can.
share even though it's recorded, so the recorded will be maybe share. Yeah.
Okay, thank you very much.
Okay. Okay, thank you
Bye.
all for
Bye.
attending the program. Thank you, thank you.